Today in Algebra 2, we're going to finish up section 5.5. So in the notes, we're skipping ahead to where it says compose functions. This is where we left off yesterday. So we're going to talk about composite functions. So this should say a composite function. A composite function is the result of applying the rule for one function f to the rule of another function g. The new rule is denoted as, it looks like the word fog, right? But that's read as f of g. So that open little o in there is read as of, okay? So this notation means the exact same thing. So you can write it at either where it says f and then that little o, g of x, or you can write all with parentheses, f, parentheses, g, parentheses, x. They both are read the same way, f of g. Okay, so it says the operation, and then that little open circle that forms a composite function is called a composition of functions. The domain of f of g is the set of all real numbers x in the domain of g, such that g of x is in the domain of f. So the domain of the composition is the intersection of the domain of g and f of g, but not f. Okay? That will make a lot more sense once we start working things out. Okay, so we're going to start out. It says let f of x equals x squared, g of x equals x plus 1, and evaluate. So my key to you is you want to work from the inside out. Okay, work from inside out. Remember, anytime we see the word evaluate, we know that we're going to get a number for an answer. Okay? So we're going to work from the inside out. So on the inside, I have a 3 with a g. So that means find g of 3. So I take g of x and I plug 3 in for x. So I get 3 plus 1, 4. Okay. So now I go outside. I go to f next. I'm going to do f of 4. So f of 4 equals, so I plug 4 into the x in my f. So f of x said x squared, so 4 squared, 16. So my answer, f of g of 3, is equal to 16. Okay? Try that again. So again, I'm taking the negative 3 as my x. I'm starting with g. So I'm going to do g of negative 3. So negative 3 plus 1 equals negative 2. So now I'm doing f of this number that I just got, negative 2. F was x squared, so negative 2 squared is positive 4. So f of g of negative 3 is equal to 4. So now it says, okay, let's write the rule for f of g of x. So if I didn't want to have to do the g first, then the f first, there's a rule, okay? So again, I start with the g. So let's just write these out again. F of x is equal to x squared. G of x is equal to x plus 1. So I start with the inside, and I plug it into the outside. So I take all of this, because that's g, and I plug it in over here for this x. So I have f of g of x is equal to, instead of x, I'm going to plug in all of x plus 1. And then it said square it. So what do I get when I square all of that? Okay, use my little shortcut, x squared plus 2x plus 2. So I could say f of g of x equals x squared plus 2x plus 2. I could check, right? Like if I took the 3, I said that it equals 16. If I plug 3 in here, 3 plus 1 is 4, 4 squared is 16. Yes. Okay. All right. Let's look at some more of those. F of x is 2x minus 1. G of x is 3x. So I'm going to evaluate. So I know when evaluate 1 and 2, we're going to get numbers for answers. Okay? So first, g of 2. We'll look on the inside. So g of 2, g of x and 3x. So 3 times instead of x, 2, I get 6. Now I want f of that. So now f of 6, so up here plug in 6. 2 times 6 minus 1. 2 times 6 is 12. 12 minus 1 is 11. So I would write f of g of 2 is equal to 11. This next one, f of g of negative 4. So find g of negative 4 first. So 3 times negative 4 equals negative 12. Now find f of negative 12. 2 times negative 12 minus 1. 2 times negative 12 is negative 24. Negative 24 minus 1, negative 25. So f of g of negative 4 is equal to negative 25. Okay? So now we're going to find the rule for f of g of x. Again, I'm going to take g of x, replace that with x, the x and the f with all of that. So I could say f of g of x is equal to 2. Instead of x, I'm going to plug in all of g, 3x minus 1. So now f of g of x is equal to 2 times 3x is 6x minus 1. That's my composition of functions. Okay. So now we're just going to focus on writing a rule for a composite function, and we're going to state the domain of that composite function. Okay. So this is f of x, square root of x plus 7. G of x, 2x minus 5. Find the composition, f of g of x, state the domain. So again, I start with the inside, g, and I go to the outside. So I'm going to take all of this and plug in right there. So f of g of x equals the square root. Instead of x, I'm going to plug in 2x minus 5. And I have to finish writing out what they had, plus 7. So that's going to equal the square root of 2x plus 2. So I can say the f of g of x is equal to the square root of 2x plus 2. Now I want the domain of this. Okay, I have a radical. It's a square root. I cannot have negatives underneath my square root. So I take what's underneath my radical, 2x plus 2, that has to be greater than or equal to 0. So subtract 2. 2x has to be greater than or equal to negative 2. Divide by 2, x has to be greater than or equal to negative 1. So the domain of the composition, x has to be greater than or equal to negative 1. Okay. Try that again. So number 2, f of x is x squared plus x plus 2. G of x is 4 minus x. Find f of g of x, state the domain. Again, they gave me g on the inside, so I start with the g. I plug it in over here for every x. Okay. So f of g of x is equal to, instead of x squared, I'm going to have 4 minus x, quantity squared. Plus, instead of x, 4 minus x, plus 2. I'm going to use my shortcut for 4 minus x quantity squared. So that's the first term squared. So 4 squared is 16. Multiply the 2 together and double it. So negative 4x doubled is negative 8x. And then negative x squared is plus x squared. Plus 4 minus x plus 2. So now I'm just going to combine like terms and put it in standard form. So I've got an x squared, negative 8x minus x minus 9x. 16 plus 4 is 20, plus 2 plus 22. My domain. This is a parabola, right? I don't have any square roots. I have x squared and x's. I can plug in any number I want to for x squared. So this is all real numbers, or negative infinity to infinity. I don't have a denominator. I don't have a radical, so I don't have anything to restrict my domain there. Okay, let's keep doing some more of those. So now it says identify the rules for f of g of x and g of f of x. So now we're going to go both ways. Okay? So if we do f of g of x, again, I'm starting with the g and plugging into the f. So instead of x, I'm going to put x plus 1, and then it says quantity cubed. We can FOIL all of that out if we want. If I FOIL all of that out, I end up with x cubed plus 3x squared plus 3x plus 1. Now we're going to go the other way, g of f of x. So that means now we're going to start with the f and plug that into the g. And so instead of x, I'm going to put x cubed plus 1. Nothing to work out there, so that one is done. Here's this one. I look at the domain. Neither of these domains are going to be restricted, so my domain for both of them, all reals. Number 2, f of x equals x squared plus 1, g of x, x minus 5. So again, we'll do f of g of x first. So take the g, plug into the f. So instead of this x, I'm going to say parentheses x minus 5, quantity squared, plus 1. Do my shortcut for quantity squared, so it's x squared minus 10x plus 25 plus 1. Combine like terms, so I get x squared minus 10x plus 26. No domain has been restricted there, so I'm looking at all reals. So now we're going to go the other way, g of f of x. So start with the f, so plug that in here, so x squared plus 1 minus 5. Combine like terms. So I get x squared minus 4. Again, that's a parabola, x squared, I can plug in anything I want, so the domain, again, both of these is all reals or negative infinity to infinity. So now we're going to look at how can we use a composite function. Okay? So it tells us clothes you wear post discounts to social media. The store allows customers to use multiple discounts. They simply need to tell the cashier what order they would like the discounts applied. On your next trip to clothes you wear, in which order should you ask for your discounts? So here we see we have a $5 off the purchase or 10% off the next purchase. Okay? So we have to decide how we want that. Do we want $5 off, then 10% off, or do we want 10% off, then $5 off? Okay? Let's just call X the purchase price. So then the first one, the $5 off your next purchase would be x minus 5. Then we'll say g of x. If I do 10% off our purchase is x, minus 10% off that, so minus 0.10x, which is equal to 0.90x, right? Okay. So let's do the compositions of the two. So let's say we did f of g of x first. So we would do 0.9x minus 5. Let's do g of f next. So I would do 0.9 times x minus 5, which would get me 0.9x minus 4.5. Right. If you can't tell by looking at them, which is a better deal, pick a price. Okay. Pick a price to test. So let's say our price is going to be $22. So if I do f of g, 0.9 times 22 minus 5, I would get $14.80. That's what I would pay. If I did g of f, if I went the other direction, 0.9 times 22 minus 4.5, I would pay $15.30. The first one is the better deal, right? This one is the better deal. So it is better to take a percentage off. So percent off, then the dollar amount off. That's going to give us the better deal. Okay. Let's do one more of these. It says, as a member of the Game Shop Rewards program, you get a 20% discount on purchases. All sales are subject to a 6% sales tax. Write the functions to model the discount and the sales tax. Identify the rule for the composition function that calculates the final price you would pay at Game Shop. So again, I'm going to say X is my purchase price. For discount, so discount, they told me 20% off. So it would be X minus 0.20 20% off X. So our discount, we could call that D of X, is equal to 0.8X. The sales tax that we pay, so my purchase price plus 6%, 0.06 times my purchase price. So our tax, T of X, would equal 1.06X. So let's say I did discount of tax. So D of T of X. So I would have 0.8 times 1.06X, which is going to give me 0.848X. If I went the other direction, TOD of X, so start with the discount and plug that in. So I would have 1.06 times 0.8X. I'm still going to get 0.848X. So the price we pay, so it doesn't matter how I write it, DOT, 0.848X. That's the equation to calculate how much you're going to pay. So here, if we do tax then the discount, we're going to pay the same as if we did the discount then the tax. All right, so that wraps up section 5.5. Tomorrow we'll start looking at 5.6. You can find your homework on Canvas.